Right, here we've got a question on moments. Mei M2 Jun 2011, question 2. I'll just show you the different parts of the question. You'll need to pause the video and read them carefully. That's the first bit. We'll come back and do each of these parts in turn. Then it goes on to this part. So pause. And then the last part of the video, last part of the question is this. Right. So coming back and getting stuck into the question, then here's the first bit. For this very first bit, we've got a support at B. They tell us the weight is 600 newtons. Let's draw that in there. Then there's the centre of mass. So this is 600. And that's a distance of 0.8 from the edge. And it's supported at B. Now in this part of the question, everything's horizontal. There's no forces with any horizontal components. All the forces will have vertical components. So the force at B we can assume is a vertical force like that, and the force at A would be a vertical force as well. There we are then. Let's call them. Let's call that one Y and that one R. So for this simple part of the question, we know from resolving vertically that Y plus R equals 600. To get R, then we'll take moments about A, and that'll tell us R times 2 equals 600 times 0.8. So R is 240. That's all they want. They don't want the other. They just want the force on the beam due to the support at B. So R is 240. And 3 marks for that question. It was an M1 and 2 accuracy marks. Right, on we go then. Now instead of there being a support at B, we've now got a different situation where we've got a wire. So this time we've got to find the tension in the wire. And we've also got to find, I'll let you get on to the end of this question, there's 2 things here. We have to find the tension in the wire, and we have to find basically the forces at the hinge. So if I slide this over a bit to give myself a bit more room, let's see if I can fit all this in on this page. Let's have a look. Right, we should be okay. I've just drawn in, I know it's not wonderful, but I haven't got room to draw another diagram really on this page. I've shown the tension in the string, in the wire, I beg your pardon. They tell us that the force at the hinge consists of horizontal force X and a downward force, vertical force Y. I've drawn them in, and the weight here at 600. The wire is fixed at 0.3 meters from the end, and the 600 is at 0.8 like it was. So for this, the usual things, we've got to form some equations. Firstly, resolving horizontally. I'm going to use every bit of space on this page. So resolving horizontally, t cos 50 equals x. And then resolving vertically, t sine 50 equals y plus 600. And moments about the end A will give us t sine 50 to give us the component perpendicular to the beam. T sine 50 times 0.3, pause the video and just try this yourself, equals 600 times 0.8. Now that gives us t directly as t equals 2088. Okay. So So using that in the top, it follows that x is t cos 50. Check these on your calculator. X is t cos 50 gives x equals 1343 to 4 significant figures. And x, putting t in the vertical equation, we get y equals, again, if you can just check this, y is 1000. So those are the forces at the hinge. Horizontal component 1343 and vertical 1000. So the actual resultant force at the hinge is like this then. Let's just change to black, shall we? 1343 there, 1000 there, and there's the actual resultant force, and here's the angle that it acts at. Let's just read the question again. We've calculated the tension, 2088. Calculate x, y, r and alpha. Well, we're nearly there then, okay. So, r equals, well, r squared equals 1343 squared plus 1000 squared. And that gives us r equals, let me look, 1674. And from the tan of alpha, in that triangle, tan of alpha is just 1000 over 1343. And that gives us alpha is 36.7 degrees. So we've got x, y, r and alpha, and that's that part done. And that gives us the direction and the magnitude of the resultant force acting at the hinge. It's force down like that. Now the last part of this question uses the fact that if you count the forces up on this beam, there's a reaction from hinge A, which we've just found the magnitude and direction of, acts at 36.7 below the horizontal. There's a tension in the wire, and there's a weight of 600. Only 3 forces once we've combined x and y. 3 forces in equilibrium. Now that should ring a bell. If there's 3 forces in equilibrium, let's just go to the next page where I've set this up. Just take a moment to read this before we carry on. When there's 3 forces in equilibrium, the lines of action of the 3 forces must be concurrent. In other words, they must pass through a point. They must pass through the same point. Otherwise, any 2 of them would pass through a point, and the third one would have a moment about that point of intersection, which means they couldn't be equilibrium. So this, if the tension in the string and the weight act through the point P, the line they've drawn from A to P must be the reaction, the direction, the line of action of the resultant reaction force at the hinge. So that's your R. Well, we know this angle then, that's alpha. So angle GAP equals alpha from the previous page, which was 36.7 degrees. That's why it's only 2 marks. That's just checking that you appreciate that 3 forces in equilibrium must act through a point. The lines of action have to pass through a single point. If you want to look that up, to think about that some more in your textbook, it might help. Right, that's the end of that part. Let's just go back and put some method marks and things in. I've done them for the very first bit, okay. For this bit here then, we've got, let me just look, we've got a total of 7 marks, which were method marks for resolving and moments. Let me just count up all the method marks first of all then. We've got an M1, effectively M1 and accuracy marks for the resolvings. Let's go in red. So, red. M1, A1, and M1, A1 there. I hope this is fitting on. It's near the edge of the screen, I know. And for the moments, we had an M1, A1 as well. Sorry, my throat is croaky. For calculating the tension in the wire, then basically we had an M1, an A1. It's 2 marks out of 5, and then the remaining was accuracy marks. There'd be another 3 accuracy marks there. And for the 7 marks for calculating R and alpha, then we've got resolving vertically gave us 2 marks each, and then that's 4, and there's 3 more for the squaring and adding M1A2 for that, but apparently we're looking at the answer scheme. So for this last page full of questions, then the 5 marks for the tension was 2 for moments, 3 for putting in the correct values, and for x, y, r and alpha it was 4 and 3, 4 for resolving and 3 for finding the magnitude of the resultant. And for the very little bit at the end, the 2 marks, that was just an M1A1, I think. Yeah, for that part there. Right, that was a moments question from June 2011, question 2. Thank you for listening.